Okay, Algebra 1B. Welcome to part 1 of lesson 7.4. We are going to start right here with this one warm-up problem to sort of get us going for what we're going to be looking at today, which is dividing exponents. We've been multiplying exponents for a number of days. Now we're going to be dividing expressions with exponents in them. Okay. To start with, let's look at this expression here. 9 times x times y over 3 times y. Now I hope that you know that when you see something in the top and the bottom of a fraction, you are allowed to cancel those things out and simplify that fraction down further. Okay? The first thing that I see in both the top and the bottom is what? It's the y here at the end of my 9xy and here after my 3. So I see a y in the top and a y in the bottom, so I'm going to cancel both of those out. Okay? So I've canceled the y, and now I have 9x over 3. The other thing that I see I can do some canceling with is my 9 and my 3. Okay? Hopefully you can see what we're going to do there. Simplify that down if you already know it. For those of you that don't, notice that 9 is really 3 times 3. So that means I got a 3 on the top and a 3 on the bottom that I am allowed to cancel out. Cancel out. Cancel with 9, and I just have a 3. So my final answer here is 3x. What do I have left on the bottom? Well, nothing. That just becomes a 1. So my final answer here is 3x. Okay? Hopefully that makes sense to you, canceling things out on the top and bottom of a fraction. And if you cancel everything out on one of them, it just becomes a 1, like we did on the bottom here. Okay? Once you understand that example problem, that warm-up problem, turn with me please to page 439, and we're going to look at division properties of exponents, or at least one of them today. Okay, division properties of exponents. This should really not say 434. Like I said, we are on page 439. All right? Here's our essential understanding, our introduction to what's going to be happening today. All right? We are going to be using properties of exponents to, instead of multiply things, to divide powers with the same base. Okay? Again, we still need to see the same base here, like on the top here and bottom, we see a 4 and a 4 in both. Okay? Really all we're going to do is be rewriting these exponents in a different way, canceling a lot of stuff out and figuring out the pattern. Okay? So here's what we want to look at first. 4 to the 5th power over 4 to the 3rd power. Okay, we're right down here now. 4 to the 5th power, we know is just 5 4s listed out and multiplied all together, right? 1, 2, 3, 4, 5 of them. Right there on the top. On the bottom of our fraction, we have 3 of them. 4 to the 3rd power is 3 4s listed out. Right? 1, 2, 3 of them right there. So in order to simplify this down, there are lots of things that we see both in the top and bottom of our fraction, so we get to cancel all of those out. So you can see we've canceled this 4 with this 4, this 4 with this 4, and this 4 with this 4. Now, what are we left with on the bottom? Well, nothing. We've canceled everything out. So the bottom of our fraction is just a 1. What are we left with on the top? 4 times 4, which we know really is 4 squared. And we see 2 of them listed out and multiplied together. We know that's 4 to the 2nd power. So 4 to the 2nd power over 1 is just 4 to the 2nd power. Okay? So notice what we've done here with the 5 and the 3 to get down to 2. 5 minus 3 gives us 2. So when we see 2 expressions with the same base but different exponents on the top and bottom of a fraction, the rule that we are about to write down says all we have to do is subtract those exponents. Just as a refresher, when we see different expressions with the same base multiplied together, what do we do with the exponents in this case? We add them. So this is 4 to the 5 plus 3, which is 4 to the 8th power. Okay, so now instead of timesing the two things together, we're dividing them with a fraction. So instead of adding our exponents, we are now subtracting them to end up here. Okay? So that is exactly the rule that I want you to write down in your notes. You'll see it there on the bottom of page 439. Dividing powers with the same base. Okay? Here in words, it says to divide powers with the same base, all you need to do is subtract the exponents. Right? So a to the m over a to the n is just a to the m minus n. And then here is a great number of examples for you. Okay? Notice, please, in this example here, we end up with x to the 4 minus 7, which equals x to the minus 3. I hope, and I believe most of you already have this in your minds, we don't like negative exponents, right? So when we get this x to the negative 3 power, we're going to rewrite it as 1 over x to the 3rd, okay? So write down these examples and these words, and then go with me to the top of page 440, and we will look at what this is going to look like in your practice problem set. So here's what I'm going to be asking you to do. And it's writing the simplified form of a great number of expressions. Okay? The first one is here. X to the 5 over 2 over x to the 2 power. Okay, well, we know when we see an x with an exponent on the top and an x with an exponent on the bottom of a fraction, all we need to do with those exponents is subtract them, which is what we are doing right there. Okay? 5 over 2 minus 2. A couple different ways you can do that. We want to be continuously dealing with fractions. So I'm going to change the 2 to be a fraction. All right, so I'm trying to do 5 over 2 minus 2, which is really over 1, right? In order to subtract fractions, I need the denominators to be the same. So I'm going to times this by 2, which means I need to times the top by 2. So what I'm now doing is 5 over 2 minus 2 times 2 is 4 over 1 times 2 is 2. And now that the bottom is 2 here and 2 here, I can just subtract 5 minus 4 gives me 1 over 2. Okay? So there's a quick refresher on subtracting fractions if you don't remember that. And that's how we end up right there at x to the 1/2 power. Because we took our two exponents, 5 over 2 and 2, and subtracted them. Okay? Now in this next example, you'll see that we have m's and n's. Now those are different bases, so we are not allowed to put them together, which means our answer should also have m and n both in it. Okay? So let's see what we do here in this example. The first thing that we're going to deal with is our m's. Again, we see m to some exponent on the top and m to some exponent on the bottom, 2 and 5 in this case. So all we're going to do right here is subtract the 2 and the 5. And we have 2 minus 5 gives us negative 3 down in the next step. Okay? Same thing with our n's. We're going to do n to the 4th power over n to the 3rd power. We know all we have to do with those two exponents is subtract them, 4 minus 3, and we end up with n to the 1 power. All right? Now, the thing that we have to notice is right here, our m has a negative exponent on it, right? Which is no good for us. So, instead of saying m to the negative 3rd times n to the 1st, we're going to move the m to the negative 3rd to the bottom of a fraction, and now rewrite it with a positive 3 exponent right there. Our n stays on the top, and you could write n to the 1st power, that's fine. But n to the 1st is really just one n listed out, so usually we just write n all by itself. Okay? So we end up here with this simplified expression. N on the top, m to the 3rd now on the bottom because of that negative 3 exponent when we subtract it. Okay? Once you feel pretty good about those two examples and what I'm asking you to do there, I want you to take a look here at these 4 examples. Write me the simplified form of each expression. Remember, all positive exponents. positive exponents. All right, so look at A, B, C, and D, please. Once you have mastered those 4 problems, then you can go with me to the next example problem where we're going to go back to science class. Okay, but I need everybody to be masters of these 4 problems right here. When you've mastered those, then go on with me to the next problem. If you work on these and find that you can do one, please make a note to ask me in class tomorrow. Okay? There's your instructions. Pause the video, do those 4 problems, then come back and we'll go on. Okay, let's go on to problem number 2, back to science class. All right? Now, we talked about scientific notation a couple videos ago when we were multiplying different expressions with different exponents, okay? Now, we are going to be dividing numbers that have scientific notation. And just a reminder that scientific notation means we see something like this, okay? 10 to the 7th power, some number times 10 to the 7th power, or times 10 to some other power, okay? This problem says, population density describes the number of people per area. Per means divide, okay? So we're going to be dividing people by area, because that's what per means. During 1 year, the population of Angola, which is a country, was 1.21 times 10 to the 7th people. The area of Angola is 4.81 times 10 to the 5th square miles. What was the population density of Angola that year? Okay? So all we're being asked to do here is do this division problem. 1.21 times 10 to the 7th divided by 4.81 times 10 to the 5th. All right? Now, 2 different things we need to do here. One is just do this division. 1.21 divided by 4.81. If you do that on a calculator, you should get 0.252. All right? The other thing we need to deal with is these 10s to some power. So here we have 10 to the 7th on the top and 10 to the 5th on the bottom. Hopefully we know, based on our rule from today, that when we see a 10 to some power on the top and 10 to some power on the bottom, all we need to do is subtract those 2 exponents to simplify our expression. Okay? So 10 to the 7th over 10 to the 5th, 7 minus 5 gives me right here 10 to the 2nd power. Okay? Now, in order to rewrite this in scientific notation, we need this number right here, this number, to be somewhere between 1 and 10, or 1 and 9.9. Okay? So 0.25 isn't going to work. But if I could just slide this decimal place over 1 space to the right, then it would be 2.52, and that would be great. Now, moving my decimal place to the right 1 space means I need to take 1 exponent number away from my 10. Okay, so instead of 0.252 times 10 to the 2nd, since I moved that decimal place 1 space to the right, I subtract 1 from the exponent. Okay? So let me write that down, because it may be useful for you in science class or in this next problem. Okay? So moving decimal to the right, oops, moving decimal to the right, subtract from the exponent. If we move it to the left, it should make sense that we add to the exponent. Moving decimal to the left means we add to the exponent. So, rewriting in scientific notation, I'm going to ask you to do it in this next got it problem and potentially somewhere in your practice problem set. Okay? If you have questions about how to rewrite it in scientific notation, that is a perfect thing to ask me in class tomorrow. Okay? But I do want you to try it here at the bottom, the got it number 2, which you can find right at the bottom of page 440. Okay, page 440, right at the bottom. Do this problem, which talks again about population density. So take your number of people and divide by your number of square miles. Okay, so number of people divided by number of square miles. Then simplify using your exponent rules and rewrite in scientific notation. Okay. If you have questions about that, especially the scientific notation part of it, please make a note to ask me in class tomorrow. Once you have mastered that problem, you will be all prepared to do your practice problem set in class tomorrow. So that is all I have for you right now. Again, if you have questions, ask in class tomorrow. I will see you then. Have a wonderful night.